wanted to sort of talk about computers and learning and education. One of the ideas I toy with on navigating patterns, or maybe not on the channel yet, but have been toying with, is what do we mean by education? And I think the problem is what everyone's talking about is formation, and nobody likes the idea of formation because individualism. I'm not going to go into that here. I'm going to talk about how that affected the computer industry. So, programming boot camps. This came up on Twitter. I don't remember the context, but effectively there was a talk about, hey, do programmers who do this first and then do this seem to do better? Yes. Why would that be? Because you can't educate somebody in programming by teaching them variables and recursion. Another thing that sort of occurred to me, and interestingly, with variables and recursion and very little else, you can do this, and yet most people haven't. Um, if you want to know how good somebody is, ask them the last time they wrote a state machine. Like, how long ago was the last state machine you wrote, and what did it do? And if they don't know what a state machine is, we're done here. Look, you can script. That's fine. Maybe you can quote program if you want to make programming into scripting. There's nothing wrong with that. Everybody needs to script. Infrastructure code is generally scripting, right? You want to get to next level infrastructure code. The next level up is probably domain specific language, right? Now, domain specific language is only a small upgrade because you're going from, we'll say, macros, right, which is just sequences of existing commands, to something a little more sophisticated. The next step after that is state machines. Just thinking about it off the top of my head. If you can't do state machines, you're not a software engineer, not able to engineer anything. Because that's where the actual addition comes in, and you're not a cog in the machine. Right? Because if you're just scripting, you're a cog in the machine. There's a procedure that needs to be followed, or maybe you need to come up with a procedure. That's fine. That's not that hard either. It's also not programming, but someone needs to do all that work. It's super valuable. There's a lot of stuff that needs to be automated, but you are the equivalent of a bricklayer. Sorry, you're just not picking up bricks. It just doesn't take a lot to do that. And someone needs to lay the bricks. I get it, right? You're not the guy designing the house. You're the guy being told which boards to nail together. Right. Nothing wrong with that. We all need that. But also, you get fooled into thinking you weren't a cog in a machine when, in fact, you always were. Proper programming education cannot be done in a boot camp. You cannot do it that way because it takes time. The most valuable thing that ever happened to me in my programming education happened to me in high school because my father was keen on chasing after computers for me as a learning experience. So I went to magnet schools, and the magnet schools all had computer courses in high school. It was a big experiment at the time. Almost none of the schools had this, right? And this is in public school even. So what happened was they gave us assignments in the class, for the semester or whatever, and I did them all the next day because I had owned 2 computers for my whole life by this point, since I was like 7 or 8 years old. Something's crazy. And so none of that stuff was hard. I knew a way to do it. So what I did during class, and the teacher let me get away with this, which is fine. I mean, this is proper teaching, right? Like, oh, there's a set of skills here that can be utilized. Let's not be greedy, right? Is I walked around the room and helped people with doing their assignments. Right? I'd already done mine. Now they're all where to just go to them in bang. I'm just, I'd already done them. It's not like I did them quickly. I had already done them. I went home and worked on them all the minute I knew what they were. And so by the time I got into class, they were all done. All I had to do is type them in at best if I didn't already have them typed in somehow. So I went around the class and I helped everybody else with their assignments. Now, what I found out in doing that was not all of the people doing the same assignment with the same goal were going about it the same way. No, I'm in high school, so, this is kind of a new experience. Like, That's a little weird because in computers, it's basically supposed to be all math, and so it's supposed to reduce all to the same thing, and that's not true. That's good to know. There's more than one way to solve the same problem. Interesting. But I was hell bent on helping them with their code and not helping me say, no, you're doing this all wrong, because that doesn't help them. And there were a few people who did the assignment, did it incorrectly. And I was like, well, I helped you do it incorrectly. What do you want from me? I'm not the teacher, right? That's not my job. And how else do you learn? You learn by making mistakes. If you're not making mistakes, you're not learning anything. And you should question everything you're doing. Sorry. You should just be doing that. And so what I learned in that was a bunch of different ways to solve a problem. Sometimes they were better than the ways I had come up with in various ways. You can't, that was more efficient. More efficient for what? Efficiency is not a good term to use ever because it's contextless. Right? Efficiency requires relationship to a telos, a final cause, a goal. Right? And one efficiency comes at the cost of another. So there's no grand capital E efficiency in the universe. That doesn't exist. Everything's trade-offs. See navigating patterns. If you want to know more trade-offs. So the education was in working with other people and seeing how they were solving the problem and also seeing their mistakes. And sometimes I didn't know what they were doing wasn't going to work because it wasn't immediately apparent to me. And not my goal, dude. My goal was to help my peers. And that's when I learned the most. Now, at that point, I knew nothing. But I still learned the most because you got to set a baseline. And so I've insisted, and again, this came up on Twitter, you absolutely shouldn't touch something like C programming at all until you've learned other things first. You shouldn't start with C. You probably shouldn't even start with Python, to be honest. The way I learned was I started with BASIC, Beginner's All-Purpose Symbolic Instruction Code, for those of you at home. BASIC is very useful. And so is, Turtle Graphics, just a subset of Logo. Logo is very useful, right? Because you get to map certain things certain ways. And then once you sort of play with BASIC long enough, and I remember this so clearly, it's insane. You kind of figure out, I had this garbage area where I kept all my variable assignments just in one place, right? That way I knew where to change them all. Right at the top of the file, usually, right? So I kept all my initializations in one place. I learned that over time, though. I didn't do that out of the box. And then I learned Pascal. And learning Pascal was amazingly helpful because it's a very structured programming language. May not be very useful, although back then, we Turbo Pascal and things like that were Delphi, unbelievably powerful systems based on that work. So you kind of learn, the freedom of BASIC, where you can pretty much do whatever you want. It's Wild West out there, right? But it's constrained by existing keywords, right? Or existing keywords is probably the best way to say it. And then Pascal, where you're a lot less constrained by keywords, but you are constrained by structure instead. Oh, very structurally constrained. And then you go to C, which is like the wild, wild west with no keywords and no structures. Now, you can build structures, right? But the language itself is much less structured. There's a bunch of holes in C. They're famous. Go look up the old C programming contests where they obfuscated C, which is a great book. It's not here. It's in the shed somewhere. I'll grab it at some point. These are amazing, the stupid things you can do in C, and the stupid things that will compile in C that probably shouldn't, right? Probably shouldn't compile those things, but they work for whatever reason. I don't know. It's kind of funny. But learning it in that order made a difference because then my C programming was decent. And then later on, years later, in some cases, I could Look at the Linux source code and format it without reading any of the code and fix it. Didn't even need to see the bugs. Why? Because I formatted the damn code. And it turns out that when you format the code, when you impose a structure closer to Pascal, on C, bugs vanish. You don't need to read the code at all. That's a whopping sort of a thing, right? That's whopping. Oh, you can just format code and fix bugs. Yes. Without even seeing them, without even reading the code, without even experiencing the bug. Yes, I did it many times in early Linux source code. I don't know if you can see those commits anymore or what name I would have done them under. Probably anonymously. I was hella paranoid back then. I knew what was coming. And, you know, off by one errors show up really, not all of them. It's not like you don't fix all of any class of bugs by reformatting code, but you can find a lot of bugs that way in a big source code base without putting in a lot of effort. And I knew this because I had experience with Pascal. And I actually knew how to code in Pascal back in the day. I haven't done it in years. Obviously, it's a teaching language. So learning it is worthless in some sense, for the most part, to interfacing in the commercial world. Even back then, that was mostly true. But it gives you a bunch of glue skills that exapt, if you want to use crazy John Vervaeke language, into other things, into other ways of programming, and in fact, into the form of how you write code, irrespective of the language. In other words, it's formation. How do you become an educated programmer? You form your habits, or hopefully have them formed to you, right? Have them formed by somebody else. You can use Nicholas Wirth if you'd like. I did, among others. I mean, I had a lot of great mentors over the years, like who showed me tricks that they knew that I never would have thought of, and probably argued with all of them about the proper format of C code. And I'm going to insist that my way is correct and all the others are wrong, because you do. Yeah, you put braces standalone at the edge of where they're bracing. Always. Really important. Also will make you a better Python programmer before Python is actually a thing. That formation is what makes you better at your craft. It doesn't matter what your craft is, by the way. This doesn't apply only to programming. It's just the thing that I know the absolute best, right? So, which is not. I'm not claiming I'm a great software engineer. I'm way better than average for sure, but I'm not a fan. I'm no Matt Dillon. Let me tell you. Dragonfly BSD? No, I can't do any of the things he can do. Sadly, very sadly. This idea of education and formation is important. You need formation. You need to be formed how to do these things in a way that exapts out. In other words, you don't need to learn the thing in and of itself. Right? Learning Python is great. I love Python. You learn Python in 20 minutes on the python.org website. You don't need to go to any special things. They have all the information you need. But if you knew C and you before that learned Pascal, learning Python is going to take no time at all. Right. So if you can't learn Python in 20 minutes, you probably haven't been formed to understand programming very well, or software engineering. We want to get really technical about it. That might be a hint about what you need to do, which is to go back to the beginning and learn these things. I mean, the number of basic programs I wrote that will never see the light of day. In fact, I wrote an adventure game once with if-then statements. And then I hunted down the Scott Adams, I think is actually his name, not the cartoonist. Scott Adams article, because I think he wrote the one of the early adventure series games, Infocoms, maybe. I think he was at Infocom, but he went into the math of how to do the map without doing if-then statements. And I mean, obviously, no one's going to play my if then adventure game that I like carefully mapped out on paper with grids and the whole 9 yards, and then calculated all the if thens for the whole map. And it wasn't huge. Obviously, it was written in BASIC on a VIC 20. I had an 8K cartridge, though, so I had a whole 11K of RAM on my VIC 20. But I did it, right? And it was correct. I validated and verified it. Like, it was correct. All the movements, northwest, east, south, couldn't move past the border. That was a bug early on, obviously, right? All in if then statements, for a, I forget how big the map is. I have it somewhere, I think. I think I have it. I think that I kept somehow. Um, I mean, it was a big piece of grid paper, so it wasn't trivially small. And I had things like a river, so if you hit the river, it would just flow all the way down to the bottom. Like I had relatively, for the time, sophisticated conditions. It wasn't just you could only move from square to square. No, it wasn't that at all. Which is kind of cool. And if you haven't coded one of those, because that's kind of involves state machines, right? Maybe you're just not a software engineer yet. Because I would argue that set of skills is needed for a bunch of other sets of skills. And I didn't use hash tables or anything, right? And sometimes, I would argue all the time when you're learning it with the basics, with nothing, no advanced tools, is the thing that gives you the knowledge to do it well. Whether it's hand tools and wood or anything else, like that's why, because the details that get lost in the technology, in the automation, in the automatic thing, are the details you need to understand to have the deep understanding. And that's the problem. That's why, even if you teach people in your high school programming class, which you're already excellent at, because I was always a good programmer because I just put in tons of hours by the time I got to a class that I knew what I was doing. And I followed a very careful, like, learning BASIC first and Logo by accident because they did it in school. I was like, really, guys? And then learning Pascal. This was not accidental. Like, I was told that was the way it should be done. I didn't come up with this by myself. Right. But doing that and, writing real software in Pascal that worked, did stuff. It wasn't graphical. Graphics is GUIs are boring. And they're derivable too, by the way. And then, learning to link your data structures with your data storage, right? And then later learning, oh, you shouldn't link your data structures to your data storage in that way. In other words, there's a right way to do that and a wrong way to do that. Or you can cheat and just do a one-to-one mapping. Now, the problem with one-to-one mapping is once data sets get large, that's actually wrong and causes performance problems that are insurmountable, even with today's hardware. Like, you can blow up entire databases by doing that, such that they can't be made fast with faster hardware. Right, because there's way more going on. Right. So, learning to differentiate and separate those two things in the right way, because there's an infinite number of ways to do it, is super important. Excuse me. And that's true for everything. Not just programming, but programming's really important when it's done as formation and not done as, well, I'm going to learn this language, or I'm going to learn this tactic, or I'm going to learn these programming patterns. I have language implementation patterns. Sure. I didn't learn anything from that book. By the time that book came out, I was already pretty good at writing domain-specific languages and stuff. So I was like, kinda. The problem with patterns, you have to know which pattern to apply when and when to make exceptions in it. That's the magic. The magic isn't the pattern. Patterns will be there, and other people will create them for you. Back in the day, everybody was creating their own freaking compiler. Why? Because compiler grammar tools were available. I mean, Yak and Lex and stuff were there. So why not write your own compiled domain-specific language? Because we used to. I mean, I wrote compiled ones and interpreted ones for obvious reasons. wrote them in Perl in some cases. That was for Perl 4, not Perl 5. Perl 5 is garbage. Perl 4 was awesome. Perl 4 is a lot like Python in terms of ability to manipulate systems code. In fact, it was better than Python at that. Unfortunately, it was impossible to debug. It's like you'd use old-fashioned debugging. I'm still using old-fashioned debugging in Python with print statements, by the way. Why? Because you have to. You never get around that. You can't. Regular debuggers don't work well with OO code at all. And they can show you simple errors, but they can't show you structural and architectural problems. They can't show you bugs in the language. There's a bunch of bugs in Python and C and stuff that you're not going to notice until you get to a certain level of complexity. And then you're going through the debugger and you see something and you're like, what happened? And you have no idea. It doesn't make any sense because it's not actually correct. And it just turns out that the math on the compiler is actually wrong in some cases. Well documented, by the way. And then, okay, well, you just have to know that. And the best way to find that is with print statements. Sorry, log files suck. Unless you do, you can do good log files, but doing good log files is hard. All of the knowledge of how to do this takes formation. Formation takes time. If you haven't been programming, we'll say professionally, although I don't want to say like for money, but if you haven't been writing software that other people use, not just you, but other people can use for 10 years, you're not good at it yet. Sorry, it's just how long it takes to learn all the things. And that won't teach you all the things. That'll just teach you enough things so that you kind of get a sense for what you're good at and what you're not, right? And when to use libraries and when not to, when to roll your own, right? Do I need my own wheel? Sometimes you need your own wheel. Like, I'm not a big fan of reinventing the wheel, but sometimes you need your own wheel. Man, the number of things I've had to oh no, I can't use this library. It sucks. It's written for this purpose, and that's not my purpose. And so I just have to write something that's 99% identical with a 1% difference. That sucks. And sometimes you modify stuff. Some GUI libraries I used to modify all the time. I just add features. Like one GUI library on the Amiga a billion years ago, you couldn't have a field that was that scrolled. So you'd have a field, but it wouldn't scroll. And I was like, well, I want the form to be regular, but I want the field to scroll. So I added in the code to do that. It was pretty easy C code, but I had to add it in. And I modified it. I don't know if I submitted that change to the author or not. Too long ago, can't remember. But knowing that that's a thing, like, oh, some GUIs need this feature. This GUI library doesn't have it. I'll add it in. Super important. And in the bad old days, the way people used to code is you take your coding library with you from company to company. So you'd have C imports, .lib files, or .sos or whatever. And that would be code you wrote to do whatever, binary trees or something special with backlinked lists or whatever. Hash tables, your own custom hash tables for certain circumstances. Everybody had their own programmer's toolbox, including me, although mine's probably long gone. Maybe when I get the new toy up and running, I'll find some of that code. If I still have it. I don't know that I still have it. The idea of formation has been lost to us. I think we can be handed knowledge from a book or through a quick procedure or by a teacher or something. And that isn't how learning works. It's not how learning ever worked. It's not how learning ever will work. That's not how it happens. We haven't been accounting for formation, structure, the things outside ourselves and how they impact us. And that's how you actually learn something properly. So that's what I wanted to go over. I hope you found this helpful. Hope it wasn't too disheartening. Yeah, you're going to do this in a certain order. You've got to program in languages and throw out a bunch of code because you'll never use it again. But it teaches you these things that once you know them, you can write good code for companies or good code for yourself in the case of stuff I'm working on. Don't rely on the AI. Ugh. Although the AI can be useful. It's fun having an AI to program with, because it makes useful suggestions occasionally. But man, the amount of mistakes it's made so far is just mind-boggling. But it's good to have people to code with. Don't code alone. That's also a mistake. You're not going to learn if you're not exposed to people better and worse than yourself. And One person can be better and worse than you at the same thing. Good news. The world is huge. And some people understand even variables in recursion better than others. Do you know what tail recursion is? Right? Can you build a state machine? When was the last time you built the state machine? What did it do? What were the possible states? Did you fully validate the state machine? What's fully validating state machines? Good question. These are things you need to know. And then someday you can get to algorithms. And that can be really fun.